Okay, so let's get so in the last lecture, so who wants to brief me what we did in the last lecture? So who wants to volunteer to discuss what we did in the last? So what did we discuss? Pick up. Yeah. So we briefly introduced the topic and discuss necessity of irrigation and types of irrigation. So today we are going to see seasons, okay, and also we will be doing some calculations on how to estimate water requirements. So generally, what are the stages of agriculture? How do you start agriculture? So usually the land or the soil needs to be mixed before you. So you start by preparing the soil by flowing, and once you prepare the soil, you loosen the soil, make sure the soil is well mixed. Then you sow the seeds. Once you sow the seeds, you start irrigating it, and then once you sow the water, of course, while the plants are growing, so in India, there are two main crop seasons. The one is during the monsoon, and the other is during winter. So during monsoon, it's called Kharif season. So usually, July. Monsoon starts arriving in early June. So if you're in South India, they start in early June. You just take a little bit of time. So, we sow the seeds when there's the first rain. So it could be from May or it can be in June. So usually if we start the cropping from June, then it is Kharif, June or April, it is Kharif season, and the harvesting is usually done in September. So after we receive rainfall in June, July, and towards the end of September is when harvesting starts. Whereas Rabi is the winter season, and usually in March. So these are the two main crop seasons that we have. And of course, some people might practice a third season which is hot weather crops. So let's say if they are cropping in February, so they're starting their agriculture in February, and they do the harvest before June or July. So that, and together Kharif and hot weather crops are called summer crops. And we can also classify the crops based on the irrigation requirement. So there could be some which do not require irrigation specifically, so which can survive on rainwater or water that is already present in the soil, whereas some other crops they might require irrigation specifically. So based on the requirement of irrigation, we can categorize as wet, dry crops and wet crops. So what are some examples for dry crops and wet crops? So what is dominant in South India? Rice. So rice is a wet crop. And how about in the northern regions? Wheat. The wheat is a dry crop. So these lecture notes I will be uploading on the Google Classroom after we finish the lecture. And I'm also recording and go back and view the lecture if you want. So this will also be posted on Google recording. Now these are some other terms that we need to be aware of. The as I said, Rabi season is during and Kharif is during monsoon. So the type of crops that we grow during these two different seasons are going to be different. And depending on the crop, the area that we use for agriculture and also irrigation is going to be different. So generally, because we require more water, so as for Rabi, we need to support it. So usually the area of irrigation is twice in Rabi compared to Kharif. And some crops they may require the soil to be prepared well before sowing the seeds. So they require some measure even before we sow the seeds. For example, groundnuts or peanuts, they require some soil moisture before you sow the seeds. So that kind of irrigation is called paleo irrigation. And core watering is the first watering that you provide to the plants. So in the irrigation period, we provide water just once. So we provide water periodically for the crops, depending on the growth. And watering that you provide for the crops is called core watering. And the amount of water that you supply is dependent on the crop that you want to grow, and also it is dependent on the local climatic conditions and also the soil. Generally, people allow about 19 centimeters of water in the first irrigation, whereas for wheat it is about 13 centimeters. So these approximations, it varies from region to region. So if you look at different textbooks, you might find different numbers as well. Is an all-round crop that you can grow throughout the year. And there is a so from that point, there is a period within which you need to supply the first watering for the plants. So that is called core period. And usually for rice, it varies between 4 weeks. It is between 3 to 8 weeks. So again, it depends on the crop. So even but if you're in different geographical locations, then the water requirements will be different for the crops. Now, these are some example crops for Kharif season. So you can see in this table when they are usually sown and when they usually expected to be harvested, and also the amount of water that is required and what is the yield per hectare. So if you there are different categories of crops for Kharif and also and sugar cane can be grown mostly throughout the year. So sugar cane overlap both the seasons, Rabi and Kharif. And sugar cane requires about 5 to 6 waterings. And in this table, you would see for each type of crop, the number of waterings that you require and the amount of water that you need to supply are in this table. Now this based on this information, we will be designing how much discharge we need to take from the river into the canal and what's the design of the canal. So this is the background information that we require for designing our canal system. So how do we define water requirements of crops? So what is the water requirement? The amount of water which is required for the plant to grow. So from the beginning, from the first watering, and how does this water requirement geographical locations? So where is the highest rainfall in India? And where is the least rainfall? So if you I'm not sure of the numbers, but so if you use the same crop, but two different regions, again the water requirement is going to be different. And when we talk about water requirement, we usually talk of the period during which we need to provide the water. So the crop period corresponds to when we first sow the seed until the total period is called crop period, and the base period is when you first provide the watering until the last watering that you provide for the plants. And the frequency of irrigation also depends, right? So it's not constant for same crop. For some crops, you may need to. For some crops, so the number of times that you need to provide water also changes, right? So for each, and usually the water is 1 to 2 weeks, like 16 days. So it could also be awareness per meter. So let's say you are irrigating some mini hectare land and you're providing some depth on top of the land. So you're providing some depth divided by the area. That would be per hectare. So let's do this simple solution. So what? So then irrigate the crop. Once you anyone who are okay. So did you fill in the form as well? Yes. Why did you? I need to attend it, right? So the total strength is 111, and I could see all 111 in the form. I told you in the first class, honesty and integrity. So those are the important things. Okay. Anyway, so let's get back to this. Who wants to derive this relationship between activity and health? Okay, let's try. Do you want to try it on board? No, let's do it. Okay, let's do it. Okay, someone has to come here and do it, or I'm gonna run on the page. So who wants to do it? Who wants to give it a try? Who wants to give it a try? So who's number 36? Who's number 36? So there are 98 in class and responses. So who's sharing it? So who wants to try this? Duty and delta. So what is duty? Yeah. Duty is area, right? Yes. So I'm representing this as D, and what are the units for it? Hectares. What is delta? So it is the depth of water that we provide for the agricultural land, right? So depth you can get from volume by area. So how much volume of water have we provided? So in duty, we are talking about 1 meter cube per second. For the whole base period. So if the base period is 120 days, for 120 days, we are providing 1 meter cube per second. So I know that discharge is 1 meter cube per second. So how do I get volume? So multiplied with the duration that we provided water for. So the area that we are irrigating is D. So we need to now check for the unit. So use consistent units, meters and seconds. And what do you get? Yes. Is it right? Is it okay? Right? So this is the relation between now since can we do this? Cubic. So what does it mean, cubic? What? Louder. Yes. Cubic meters per second. what do you 1.2 meters. Did everyone get it? So we have derived the relation between delta and duty. So delta is 8.64 B by D. So the base period is 120 days, and the duty is 864 per unit. So you simply substitute B and D, you should get 1.2 meters. Now we briefly picture. So usually when we have a river, we draw water from the river into a canal, and from the canal we divert the water into branch canals. From the branch canal, we will be again drawing water to major and minor tributaries. So once the water comes, so that is where we divert water from the tributary into the sea. So as irrigation engineer, our responsibility ends in the field. So this, the entry is called usually the outlets to the field. Our responsibility lies in bringing water to the outlet. And inside this field, it is up to the water. Now, let us say I am sending in 1 meter cube per second. And I want here into the field 0.5 meter cube per second. So that is my ideal requirement. So I'm taking in 1 meter cube per second from the river, and at the field I want to have 0.5 meter cube per second. So what do you think happens in reality? So what do you expect? Do you expect the discharge to increase or decrease? Decrease. So what are the reasons for that? Louder. Seepage, friction, so the water may be delayed. And what happens because of the sun? Evaporation. So there are several losses that contribute to the loss in. So in this case, if my expectation I may only get 0.3 meter cube per second. So because of these losses, the amount of water that I need to take into the canal has to be higher than my previous estimate. So now what happens because of the loss? The area that we can irrigate with the water that we supply would be reduced. So earlier we might have expected 1,000 hectares to be irrigated, but now it might reduce to 800 hectares or 700 hectares. Goes into the canal. Now let's take this example. So 1 meter cube per second is entering at point A into the canal system, and then loss by the time water reaches the field. If in the field my estimation is that 1 meter cube per second can get 1500 hectares. So my duty is 1500 hectares, provided I have 1 meter cube per second. Now there is a loss of 30%. So what would be the revised area that I can expect to be irrigated? So the new discharge, so I'm sending in 1 meter cube per second. There is a loss of 30%. So what would be 30% of 1? 0.3. So now I'm only getting 0.7 meter cube per second. So now the area that I can expect is only 1000 hectares, close to 1000 instead of 1500. Whereas the duty at A, if your field was close to A, then you would get close to 1 meter cube per second. Then your duty may not change. Now let's say we have observed there is a loss in the discharge, and now we have increased the discharge at point A. Instead of 1 meter cube per second, we are taking in 1.3 meter cube per second. Now at point A, instead of 1 meter cube per second, we are giving 1.3 meter cube per second. So the duty is going to change. So the duty would be 1154. Now, what are the factors that impact the duty of water that is applied? So what happens? What happens if you take the type of loss of the bank and not get it? So what happens to that type of crop? So for each crop, the water requirement is different. So if some crops we are supplying only 1 meter cube per second slow, then the area would be smaller. And the water requirement is low, and we can irrigate higher areas. So, okay, so from next class, I think I will divide into teams. So whoever answers, they get a point. The team A, B, D. So let's do this. So whichever team wins. So how can climatic conditions change the duty? Okay, so today team C is winning. The team E, climatic conditions, how can they change? Yes. The temperature, then good moisture. Okay, so if that region requires that you need to supply would be reduced. So let us in irrigation we discussed two things. One is bulk storage, and the other irrigation. What happens to be stored, and then since we have some water after we can supply water. So what about method of irrigation? So this we have not started yet on method of irrigation. there are different methods of irrigation. You might have heard drip irrigation and others. Quantity of irrigation water, clean water. So how can does quality water impact our health? So what do we need from water? So plants need nutrients. So the water quality should be enough to get that. Okay, so who was that? I'm coming there. Attention, team D. So we cannot be providing the water throughout the base. So if you do not follow that regular interval or request water off, then you might excess water sometimes. Or if you provide less water sometimes, and also change how plant growth is affected. So if the plant growth is changing, then the water is also going to change. Type of soil, team B. Yes. The percolation of water can change with the type of soil. So that will impact the duties. Now can be your yes. So each canal system might have different types of losses. Yeah. How do we improve the duty? So we have seen what can impact the duty. How do we improve it? So based on this, what can we do? Let's take a crop. Or crop time, then the soil and that impact the further plant growth. You want to do a new crop. And what canal conditions? How can we improve the canal conditions? So back in 2012, in this class where you all studying, 2012, 12 years ago. Class 4. When you are in class 4 in Gujarat, so they implemented solar panel on panels. That reduced evaporation. So they were getting both benefits of generated energy and also stopping evaporation. Not stopping, but reducing evaporation. So that was first our pilot case that was done. So you can also take some measures in the properly prepared for irrigation. And it has to be leveled. And then there has to be proper channels within the field for the water to be transported. So those kind of suggestions we can make for the farmers. And in case of canals, we can provide some sections of canals where there is higher evaporation. You can provide lining or RCC. And the source of water, as I said, if your field is close to the entrance of the canal, then you get higher duty. If your field is much far from the canal system, you see losses. And so the water that is delivered to your field is going to reduce. Now, there are other types of duty we can discuss. So far what we discussed is duty water that we draw from a river, from a perennial irrigation system into a canal, and that is called flow duty. So far what we discussed is called flow duty. Now, if you're taking water from, let's say, from a well, so that is called duty of flow. So how much land can the water from the well irrigate throughout the day? That is the duty of the well. So just like duty of the students, duty of the teacher, and the duty of the well. And there is duty. So let's say you pointed out there is a rainfall. If there is a rainfall, then the amount of water that we need to supply can get reduced. So if there is 300 mm of rainfall, then the delta can be reduced by 300 mm because that is being compensated by rainfall. So one is including rainfall, which is the delta, and the other is excluding rainfall. So you just subtract from the delta, sorry, not from the duty. So from delta, you subtract what is the rainfall and exclusively what you are getting, what you are avoiding water. So that is duty of water exclusive of rain. For example, the wheat requires a water depth of 375. So the delta is 375. And the is first, what is the duty of water? So whoever finishes don't say an answer, just raise your hand. Okay, so team B has done. Which other team? So who else has done what is the duty? Okay, so we have last few minutes. So I want to do this. So each day, as I said, we have 5 days. So each day, one member from each team has to come and summarize what we did. So today, from team A, somebody has to come here and explain. Whatever you can speak. So there is no right or wrong answer. Just whatever you can. So, someone from team or we'll go in order. Yeah. So there is some that either you have to come or now you have to tell someone else. Or you have to yeah, let's hear it. No, very briefly. It's not right or wrong answer. Everybody will get it. It's you with us. You can speak whatever you want. I just want you to be here and show you. So there is, like I said, there is no right or wrong answer. There are no answers there. So I'll upload these answers in the class classroom as well. So yes, please come. What's your name? Srinivas. Srinivas. Yeah. whoever is going to laugh. Yeah, whatever you remember. Also, statement related to eat and also derivation. Related to, we have changed